Hello everyone, my name is Chhabhaiya Devanshi from CE department, ID number 20CE011. Today I am going to give you a brief introduction to microcontrollers, also known as MCU. Full form is microcontroller unit. Microcontrollers are interesting little machines that are truly amazing. So let's try to find out what they do and why we require them. So what is microcontroller? Microcontroller is an integrated circuits, also known as a chip that is programmed to do a specific task. They are pretty much the most basic form that I could formulate, that they are very small chips. In simple words, it is mini computers. Another term to describe a microcontroller is embedded controller, because microcontroller and its support circuits are often built into or embedded in the device they control. Next is these are the components: CPU, interrupt control, ROM, RAM, timer, oscillators, bus control, I/O ports, and serial ports. These are the basic main components of the microcontroller. In this CPU, the work of the CPU is it is the main part of the microcontroller that actually does all the processing works. It performs all the logical and mathematical operations. The CPU is internally connected or interfaced with the memory units such as ROM and RAM, and it works according to the instruction or programs stored in the RAM. At the starting of the processing, it fetch all the data from the ROM and performs accordingly. Then next is interrupt control. For example, the CPU performs any logical operations, but the user wants to do some more important arithmetic operation immediately. So here the interrupt system helps a lot to stop the current operation of the CPU and start the new operation. Once the task is completed, the CPU again starts its own work from where it leaves. In another words, we can say the interrupts help for the emergency operations. The next one is oscillators and timers. They are an electronic pulse signal generator circuit. It provides the pulse signal to the CPU to complete its operation and to work with the cycles per unit time. Next one is memory unit. The 8051 microcontroller has 4 KB kilobyte ROM and 128 byte RAM in the microcontroller. ROM is used for the preloaded or stored program, and RAM is used to store the temporarily during the operation or program execution. Then the next one is bus. In the microcontroller, the bus is connects all the circuits and components to the CPU. And last is input output ports. The microcontroller has 4 parallel 8-bit ports such as P0, P1, P2 and P3. These ports are bidirectional and used to carry the both address and data in the microcontroller. The next is how does microcontroller work? So microcontrollers can take input from the device they controlling and retain the control by sending the device signal to the different parts of the devices. Like a good example is TV's microcontroller. It takes input from the remote control and delivers its output on the TV screen. Microcontroller processes the data given to its input pins using its CPU and gives output via the output pins. For example, a car might have many microcontrollers that control various individual systems within it, and such as the anti-lock braking system, traction control, fuel injection or suspension control, like this. And all the microcontrollers communicate with each other to inform the correct actions. Some might communicate with more complex central computer within the car, and other might communicate with other microcontrollers. They send and receive data using their I/O peripherals and process the data to perform the designated task. Next, we'll see the difference between microprocessor and microcontroller. The main difference is the system requires more hardware, and it makes the circuit more complex in the microprocessor. While in the microcontroller, the hardware is reduced due to the single chip microprocessor system, where all the circuits are inbuilt and internally connected. In the microprocessor, it is microprocessor are little expensive, while everything comes in inbuilt in the microcontroller, so the cost of it based system is low as compared to the microprocessor based system is more flexible from a design point of view, as one can adjust the size of the RAM, ROM, and other circuits as per the requirement. While in the microcontroller, they are very less flexible, as the memory and IO devices are all the inbuilt and fixed. In microprocessor, it contains arithmetic and logical unit. Other than that, general purpose registers, stack pointer, program counter, clock timing circuits, and interrupt circuits are all the in the microprocessor. While in the microcontroller, it contains the circuitry of the microprocessor. In addition, it has inbuilt ROM, RAM, IO devices, and timer and counters. Next, we'll see the advantages of microcontroller. The main advantage is that microcontroller requires very less efforts in designing. And next is the overall system cost is very low because the circuits are integrated into the single chip, and the product size is very small as compared to microprocessor based system. As the circuits are integrated with a microprocessor, the system is more reliable. It is easy to use. Troubleshooting and system maintenance is very simple in a microcontroller. So these are the advantages of microcontroller. Next is the where the microcontroller are used. The appliances in which the microcontroller are used, that are the calculator, home theater, TV, telephone, microwave, washing machine, alarm clock, watch, and robotic system. These are the appliances where the microcontroller is used. Next is these are the types of microcontroller. Basic types are 8-bit microcontroller, 16-bit, and 32-bit. These microcontrollers are very commonly used in today's world. Then next, these are the popular microcontrollers examples: 8051 Intel, 80386 PIC, 68HS HC05, and Z8. So this is all about the microcontroller. Thank you.